Hey there, everyone! Welcome back to our channel. If you're passionate about machine learning or just curious about how artificial intelligence works, you've come to the right place. Today, we're diving into an essential concept in neural networks that can significantly improve their performance: dropout. So, grab a cup of coffee and let's get started. But first, have you ever wondered why some neural networks perform better than others? What if I told you that a simple technique called dropout can make a huge difference? Let's explore how dropout works and why it's such a game changer in the world of deep learning. To understand dropout, let's start with the basics of neural networks. A neural network consists of layers of interconnected nodes, or neurons. Each neuron takes in inputs, processes them, and passes on the output to the next layer. This structure allows the network to learn complex patterns from data. However, one common problem that arises when training neural networks is overfitting. Overfitting occurs when a model learns the training data too well, including its noise and outliers, which means it performs poorly on unseen data. Imagine you're memorizing a textbook instead of understanding the concepts. You might ace the test on that exact book, but fail when faced with a new question. This is where dropout comes in. Introduced by Geoffrey Hinton and his team in 2014, dropout is a simple yet effective regularization technique designed to prevent overfitting. So, how does it work? During training, dropout randomly drops out a fraction of the neurons in a layer with a certain probability, typically between 20% to 50%. This means that during each forward pass, some neurons are temporarily removed from the network. The result? The network learns to rely on different subsets of neurons, making it more robust and less likely to memorize the training data. Let's take an example to illustrate this. Consider a neural network designed to classify images of cats and dogs. Without dropout, the model might learn to recognize very specific features, say, the shape of a specific dog's ears. But with dropout, the network has to learn to identify cats and dogs based on a broader range of features, like fur texture or body shape. This leads to a more generalized model, which performs better on new, unseen images. In fact, research has shown that using dropout can lead to a significant improvement in model performance. In one study, models that employed dropout achieved up to 5% higher accuracy on test datasets compared to those that didn't use dropout. That's a notable difference in the world of machine learning. Now, you might be wondering, how do we decide on the dropout rate? While a common starting point is 0.5 for hidden layers and 0.2 for input layers, it's essential to experiment with different rates to find what works best for your specific task. Too high a dropout rate can hinder learning, while too low may not combat overfitting effectively. Importantly, dropout is only applied during training. When we evaluate the model or make predictions, we use all the neurons, but we scale the outputs based on the dropout rate. This adjustment ensures that the predictions remain reliable and accurate. So, to recap, dropout is a powerful technique that prevents overfitting in neural networks by randomly removing neurons during training. It encourages the model to learn more robust features, leading to improved performance on unseen data. It's a simple yet effective way to enhance the generalization ability of your models. If you're working with neural networks, I highly recommend incorporating dropout into your model training. It's an easy adjustment that can lead to significant improvements in your results. If you found this video helpful, please give it a thumbs up and subscribe for more educational content on machine learning and AI. And don't forget to comment below with any questions or topics you'd like us to cover next. Thanks for watching, and see you next time.